Alright, so we're going to use the idea of polar coordinates, which is just another way. We have our Cartesian coordinates, which are x and y values, and give you an ordered pair. And then we could also talk about that as rotating a distance, taking a distance and rotating an angle, which is an r and theta value. And so we can go back and forth between the two. But basically, if you superimpose them on each other, you can get, using just right triangle trig, some values to relate x, y, r, and theta using sine and cosine. So we'll just go back and forth between the two. We'll have certain types of graphs. We'll have a different type of graph paper called polar paper that would allow us to graph these shapes. But these are the relation between them. So again, just looking at right triangle trig, x is r cosine theta, y is r sine theta, and that's going to allow us to go back and forth. And we use our Pythagorean theorem to relate x squared plus y squared is equal to r squared, as that's the hypotenuse. And then theta is our arctangent value of y over x, which is opposite over adjacent. And so if we remember our arctan value, what that's looking for is looking for an angle. If we have a quadrant 1 angle, so xy is right there, that's fine. We have positive values. We get a tangent value of theta, which is positive. But we would have the same ratio 180 degrees or pi radians away from that angle. And so we wouldn't know necessarily which of those is our appropriate angle, so we have to really kind of think about it after the fact, and if we need to move an angle, we move an angle. So we either have to add 180 or pi if we know that we have, as opposed to a positive value, we have some negative values. And so it's just something to keep in mind as we are finding these values of keeping track of which quadrant we're in. And so we know that it only gives these two quadrants, so between 1 and 4, so negative 90 to 90, everything in there gives our full tangent ratios. And so again, if we have a quadrant 2 angle, we're going to have to move it because we'll get the angle in quadrant 4. We'll have to manipulate it so that we get the right quadrant as we're moving forward. Alright. And in general, this is our equation to get all of them. Right? This is just within the quadrant that we have right here, and we add values of pi to move it to the desired quadrant, knowing what we have, which gives us our full circle. So here's some examples of how this works. If I have rectangular or Cartesian coordinates, I can relate them with our r cosine theta and r sine theta, and I can get r squared first by just squaring x and y, and if I work through the math correctly, I get r is 4. And then theta, it's a quadrant 1 angle because I have a positive and a positive value. And so then I'm going to use my arctangent, which is going to give me the correct angle because it's already in quadrant 1. Same idea for the next ones. This is quadrant 3, so I'm going to have to move it there. After I get my arctangent, I get r, and then I take arctangent for theta. However, since this is quadrant 3, I'm not going to have the correct value that my calculator will give me, and so I need to move it there directly, and I get my value. And so if I remember my unit circle values, this is going to be 60 or pi over 3. Since it's quadrant 3, I need to add pi to it, which is my 4 pi over 3 value. Same thing with the last one. I have Cartesian coordinates. I would then square x and y. I would take my values. This one is a little bit easier in that I can see that x is 0, y is negative 8 root 6, so it's just straight down. So that's my pi over 2. That should be 3 pi over 2 to get me to that quadrant for my rotation, or negative pi over 2. Alright, if I have r and theta, same idea. X is r cosine theta, y is r sine theta, and I just plug through it, and I get my values in terms of x and y. And I can check it to think if this is in the right quadrant. So if I rotate by an angle of 2 pi over 3, that's going to put me in the second quadrant, so I should have a negative x value, which I do, and a positive y value, which I do. And last one here, again, I just relate them. X is r cosine theta, y is r sine theta. Plug through the math, and we're going to get, using our unit circle values, something that is, our values are negative and positive. And so, in this case, I have a rotation. I have an r is negative, which is actually going to flip this angle. So I would go pi over 6, but then the opposite way, which is going to take me, instead of the first quadrant, is going to take me down into that third quadrant. Alright, and then if we want all of them, then we want to add and subtract values of 2 pi. And we can do something like that on polar paper. So this is polar paper. It's radially spaced. It's not Cartesian where it's little squares, but instead goes out with concentric circles. And these are your angles, those linear marks, and then the circles are how far out R has gone. So this would be R is 1, R is 2, R is 3, R is 4, so on and so forth. And so this would mean that I'm going to move to the left. So I would go to the left and then rotate pi over 6. That's one way to do it. You could also go pi over 6, so you could go out pi over 6 and then rotate down. So this is your pi over 4, this is your pi over 6, and then you could take it and then go 180 degrees from it for the negative 4 part. You get in the same spot. Alright, so again, this is for equations. We use the same things from before. We're going to again want to know these. These are how we relate them. This is r is 4, that's r squared. If x is 2, that's r cosine theta. And so then I have my value for r, which is 2 over cosine theta. This is my value for r squared. And then I put in, for x, I put in r cosine theta. And then I get something with r where I can factor pieces out and get an equation with just r and theta. And that allows me to solve for r. So if those are 0, right, then r is 0, or r is 6 cosine theta. So that's how I can use my values to solve equations. Alright, know the other way as well. So r is x squared plus y squared is 16, if that's an r squared, which would be 4, 16 squared. So it's a circle, right? Tangent inverse of x over y is pi over 4. And so if I take tangent on both sides, right, I get this, where x over y is 1, y is x, that's a line. If I was to, and it's not a full line, right, because I only have that theta value. So if I was just to graph it before, that's the line y equals x, where x and y are both positive. I don't have the negative values on there because that's a different angle rotation. For the next one, that's 1 over sine of theta, and I have r on that side. R sine theta is 4, r sine theta is y equals 4. That should be a horizontal line. And so for the last one, I have theta is pi, and I take the tangent inverse of that, and I get y over x equals 0, which is my y equals 0, only along this line though, because again, I'm restricted to theta equals pi, which is a rotation of pi, which is right there. Alright. The domain matters, right? So you got to be a little bit careful. The range will also matter for these, but just be aware that even though you get a line, you don't get the full piece because you're only talking about one part, one rotation of an angle. So if you're to graph these, you can start with a table. You can also put your calculator in parametric mode. I'm sorry, not parametric, in polar mode. But just plug in values. So you just plug through using this equation here, and as you start to plug through, you get your values of pi, pi over 4, pi over 6, pi over 3, and you get all of these pieces. You start graphing it, and eventually you're going to get your shape that you can come up with. And some of these shapes look a little bit strange, and so you probably want to check them anyway on your calculator, so make sure you know how to put it in polar mode, and you can see that we get our circle. And if we were to take this and put it back into our value for take it in Cartesian mode, we'd find that we'd have a circle, and we'd have different values that we can see attached to it with our radii in our center. Alright, here's another one. Again, we label our pieces. We have here, we put in points, and we throw them in. Again, going a little bit quickly, we plot those points. And then if we get the negative values, right, for negative r values, they're going to map back the other way. And so what we get is this little, looks almost like a snail shell. That's half of it. If we plot the other half, we get this thing called a limacon, which has this like dimple in the middle. And there's all sorts of loops that you can see, and so you can try the difference of these, looking at ranges and restrictions on A and B, and you'll see that you get different shapes as you go through it. We can also get roses, and so if we have a value, right, we have some value for sine of theta. If n is odd, we're going to see we have some sort of shape, and if n is even, we have 2 times n, and we'll see why it happens in a second. So we just make a table, and we start plugging in points. And so what we want to see here is theta pi over 6 plus 2 pi. So I plug in pi over 6, I get 6. Plot the points, and I'm going to get larger and smaller. I'm going to have 0 when sine of 3 theta is 0, which means that theta is going to be pi over 3n. And so any of those values I come back to, I'm going to be at 0. So I get these loops coming out, which is going to make it all rose shaped. And if I was to continue my point, I could again see that I'm just plugging in these multiples looking for the 0s and the 6s, and that gives me my shape for my rose. It has 3 petals in this case. Alright, here's one more. And if I think about when is this going to be the largest, well, it's the largest when cosine, the largest value of cosine you can ever have, right, is 1. And so when this is 1, cosine of 2 theta is 1, then I'm going to be able to get 8. And so when theta is 0, you get a cosine value of 1. And so any multiple of that, of pi n, is going to be 8. So I get 8 at the 0, pi, and 2 pi. And I can see it's going to be negative 8 when I have a rotation where I have an angle of pi, so a full rotation. And we can get the same piece over here and get my negatives, and the negatives flip-flop the other way. And I have my zeros as well, and I'm going to get my shape to be, in this case, a 4-petaled rose as we go through it. So I get my other ones. Again, just plotting in points or using the calculator. And what we see is we get 4 petals on our rose.